Hey woodworkers. So talking about using a table saw to cut a groove into this board, and so I'm going to do it with something called a Dado blade, which is different from a single blade. So a single blade typically has a kerf of about 1/8 of an inch. You can also get thin rip blades that are narrower. But for what we're talking about, we need to do two things. We need to arrive at the width of the kerf that I need to do, and I also am aiming for, or would like to have, a flat bottom on the inside of this groove. So in doing that, I can make a single pass with this blade, 1/8 of an inch, and then bump the fence over, and then do another pass, and then I could probably achieve that 1/4 inch mark fairly easily. But depending on the blade you're using, you're not going to get a flat bottom on that kerf. So in doing that, it's good to know about Dado blades. So in changing this out, I've raised up the blade. Some saws require two different wrenches. Actually, most of them do. Oops, wrong one. So there is a nut on the inside of this this saw. It's held on the arbor. The arbor holds the whole thing together. And what I was going to get at is that some saws, depending on if it's a left tilt or a right tilt saw, will have the nut on the left hand side, and in which case the threads are counterclockwise. If the arbor is on the other side, where the nut will be found here to the right, then those threads are going to be clockwise. And the rationale with that is, as you turn the saw on and the blade starts to spin, this nut will continuously start to get a little bit tighter, especially when over a load of cutting. So just be aware of that if you're trying to thread on a left tilt saw. Actually, I have a right tilt, sorry. If a right tilt, the threads are going to be somewhat counterintuitive, so just be aware of that. All of this is a long way around saying be careful of doing what every woodworker dreads, which is not sharpening, but it is dropping this nut in the bottom of your saw. Usually it's full of sawdust, and finding this nut becomes a bit of a chore. Okay, so having said that, these are Dado blades, and it has a flat tooth on every third tooth, so I will be able to get that flat bottom on the groove that I'm cutting. So the 1/4 inch mark is what I'm looking for. This set has this really great cheat sheet of dimensions that you're looking for. It'll tell you which of the cutters you need to use. So I'm using 2 of the outside cutters. It also has these individual chippers, and these come in different dimensions as well. So this one is greater than a 1/4 inch, and then we have, I'm sorry, greater than 1/8 of an inch, much closer to a 1/4, and then they have some narrower ones as well. So by stacking these between the 2 outside cutters, then I can start to dial in a specific dimension. It also comes with an assortment of different shims, and you place these shims between those chippers, and then you can dial in any dimension in theory that you want within reason. You're going to run out of arbor eventually, so you can't continue to stack a bunch of these things in. It'll handle all of these chippers, but if you were to have a second set for some reason, you eventually run out of space. Alright, so I just need the 2 outside cutters. Going to clear this out of the way. When setting these up, I want to make sure to alternate where the position of the teeth are, and I want to get the body of the blade or the plate to seat flat together. If I shift these, and I'm not cautious about what I'm doing, I'm going to lock these 2 teeth together, and so I get a greater width. But the bigger issue is that these are carbide teeth and they're fairly brittle, And so if I tighten this thing down, any amount of contact between these two teeth will start to compromise these teeth, and they'll start to chip or start to break apart. So seating these things correctly, there's this little washer that goes on, and this nut, this is always the critical part. There's not a lot of clearance in here, as many of you know, if you're trying to change blades. So seat this properly. Now when we tighten this thing down after reassembling, I really don't need to break a sweat. I don't need to make this thing lock tight or solid. I just need to get it snug. And so what I've done, I've embedded this wrench against the bed of the machine. Just give this a little pull here, and that's it. That's it. This thing is not going anywhere. And as I said earlier, as soon as this is under load, it will start to tighten down this nut just a little bit. Okay, so the blade is set. Now with my throat plate, this one has a large enough clearance to accept this 1/4 inch. If I needed to have a larger dado in place, I've created these additional throat plates here. It's hard to find factory made from this table saw, just basically because the age, I haven't made it in decades. So I had to make my own. So not much to it, but these, and I have a blank here, so whatever dado I would have in it, I would put this in place, I would drop the blade all the way down, and then I would probably clamp the fence on top of this, but well outside of where the blade is going to be, and then start slowly raising up the blade until it cuts through this plate. And so you get something that has a zero clearance situation, which is kind of nice, and it definitely saves for chipping and tearing. Okay, so hopefully that made sense. In anticipation of making this groove, I need to raise the blade up. And my rule of thumb is that I never want to breach the halfway mark of the board's thickness. So if eyeballing this thing, let's say that's the halfway mark. I want to slide this blade back and forth until I can see where the peak of this tooth is going to hit. So lowering this blade, I can see that's a little bit closer to where I want to be. And then now I've dropped the blade. I want to always end with adjustments by raising the blade up. So right there is where I want this to go. Kind of rotate this around. I'm also locking this into place with a little locking nut. Alright, so that looks pretty great. So the setup here is just about done. The next thing for doing this dado on this particular application, because I already have joinery made, I need to establish this cut for where I've drawn this. It needs to be between these two pins. If I were to shift this over, I'd be cutting through this pin back here, and you would see it from the end. So this would be an exposed groove, and that just looks kind of bush league, amateur. So I want to make sure to get this and bury it here, and I could do a different application for the tail so it wouldn't be seen there as well. But this is where I want this to be. I will slide my fence over, and I'm able to sight down here and gauge exactly where this is going to happen, and that looks pretty great. Checking on both teeth to the right and to the left, and I'm pretty happy with all of that. Okay, cool. So set the blade for the thickness, set the height in relationship to the thickness of this board, move the fence over. At this point, it's just a matter of cutting it. I get into the habit, and I recommend this for everybody, marking out exactly where you need these things to go. If I didn't mark this, if I was just measuring this, it would be so easy to cut this upside down. So I would be cutting it on the outside of what this thing is going to be. By marking it here, and I've made a very small mark here outside, I've also marked left and right, so I know exactly what needs to happen. So as I'm cutting, I want to make sure to see these marks. I don't want to see where this groove mark is. If I see this as I'm cutting it, I'm cutting on the wrong face. It's just so easy to invert these if you don't have a process in place. So, okay, that's that. I'm going to turn the saw on. Eye protection's in, hearing protection's coming. There we go. Alright, nothing to it. Pardon me. So the thing I wanted to point out, as I was making this cut, I was trying to keep good pressure down, always keeping the board nice and tight against the fence. A good rule on the table saw in general. As I was pushing it through though, I'm not holding right on top of where the blade is. I'm holding just outside of this area. If I've done this, then I can hold and push all the way through. It looks a little bit different from a ripping application where this is a single blade and I'm trying to push a board all the way past. There will then be two boards after you make the cut. I would always have to push that piece and not really worry about the waste piece. This one, because I'm not separating this, I'm able to keep my hands engaged on this side the entire part of the process and go through. Alright. And I can just barely see a little bit of my line here. This is maybe a better example that you can see that I've split the difference of the lines that I've created. And then the other thing is the location here. So you can see there's still some material here between the pin and where this groove is. So all said, I'm happy with this. This is a successful cut. Alright, I'll see you in the next video. Thanks.